Imagine standing in a kitchen that looks more like a scientific research facility. Stainless steel surfaces gleam under bright lights, an array of precision instruments surrounds you, and instead of a traditional chef's uniform, I'm wearing a crisp white lab coat. This isn't just a kitchen. It's a portal into the molecular world of cooking. My name is Winifred, and I've spent the last decade bridging the gap between culinary arts and scientific research. Today, we're going to embark on a journey that will transform how you understand cooking forever. Cooking isn't just about following recipes. It's a complex dance of chemistry, physics, and pure magic happening right before your eyes. Let's start with what I call the flavor explosion, the Maillard reaction. Most people know it as the reason why a perfectly seared steak develops that incredible brown crust, or why bread turns golden and delicious. But what's really happening is a beautiful chemical romance between amino acids and sugars. When heat meets proteins, something extraordinary occurs. Hundreds of complex flavor compounds are created in mere moments. It's not just browning. It's a molecular transformation that creates over 600 different flavor compounds. Imagine tiny flavor molecules dancing and combining, creating a symphony of taste that your tongue interprets as that mouth-watering rich flavor we all crave. Take an egg, for instance. When you crack it into a hot pan, you're witnessing one of the most dramatic molecular transformations in cooking. Proteins in the egg white are initially coiled up like tiny molecular springs. As heat is applied, these proteins start to unwind, a process we call denaturation. It's like watching a microscopic ballet. The protein molecules stretch out, then tangle and reconnect, forming a solid structure. That's how a clear, liquid egg white transforms into a firm, opaque white. The temperature matters tremendously. At 63 degrees Celsius, egg proteins begin to set, creating different textures depending on how long and how hot you cook them. Water and oil are culinary enemies. They naturally repel each other, refusing to mix. But in cooking we have a secret weapon: emulsifiers. Take mayonnaise, for example. It's a miracle of science where oil and water are forced into a stable relationship by egg yolks. Lecithin, a molecule found in egg yolks, has a unique structure. One end loves water, the other loves oil. It acts like a molecular matchmaker, allowing these typically incompatible substances to create a smooth, creamy emulsion. Each time you whisk mayonnaise, you're essentially creating a microscopic structure where oil droplets are suspended in water, held together by these incredible emulsifier molecules. A pressure cooker isn't just a kitchen tool. It's a physics experiment. By increasing pressure, we're fundamentally changing how water boils. Under normal conditions, water boils at 100 degrees Celsius. But inside a pressure cooker, that temperature can rise to 121 degrees Celsius. This higher temperature means faster cooking and more profound chemical reactions. Tough collagen in meats breaks down more quickly, transforming into gelatin. Flavors develop more intensely. It's like time traveling in cooking. What would take hours now happens in minutes, without losing the depth of flavor. Cooking is humanity's first and most intimate science. Every time you step into the kitchen, you're conducting experiments. You're a scientist, an artist, a creator of molecular experiences that delight the senses. The next time you cook, remember, you're not just preparing a meal. You're orchestrating a complex ballet of molecules, transforming raw ingredients through the incredible power of chemistry and physics.